Sasanko, can I start?
Yes, you can start.
Okay, it is live, right?
Yeah.
Okay, just check in YouTube once.
Yes, it is live.
Okay, thanks. Okay. So a very good evening to one and all present virtually in the 27th webinar of Assam Artificial Intelligence I. We are delighted to inform you that in this version of technical lecture series, we invited Dr. Jaimini Bhattacharyya. He will discuss the application of data science in supply chain management, and he will talk about like how supply chain management works and how data science and AI/ML algorithms can be applied. So this will be a very great discussion, and you can ask questions or YouTube chat box. Uh, so Gemini is currently working as a staff operations research engineer at Micron Technology India. He completed his PhD from IIT Madras. Gemini has rich experiences in the field of supply chain analytics, optimization, and data science. He has previously worked for Royal Dutch Shell oil and gas company and Target Corporation in these particular domains for like supply chains and uh, applications related to data science. And he is also a visiting faculty member of data science at IIT Madras. So, Jamini, you can present and you can continue your presentation.
Thank you,
Thank
Sincere,
you.
for the nice introduction. Uh, yeah, in this today's talk, a very good evening to everyone. And in today's talk, I will cover up a basic introduction to supply chain and a few problems and a couple of use cases from my experience, and also how the data science can be useful for optimizing and designing a supply chain. So we will start. So this is the agenda. First, I will cover up the basic overview of a supply chain. So here I will give you a couple of examples and what are decisions involved in a supply chain optimization and design. And I also included three use cases actually, one from the wind turbine, one from maintenance scheduling, and another from the retail industry. And the last part, maybe to the relevant audience, I'll just cover up what are the careers in this field of supply chain. So first, see what is a supply chain. Basically, a supply chain, when you define, it is told that in this world everything is a supply chain. So like we are surrounded by supply chains for every product, every company. There is a supply chain exists. Suppose I'm manufacturing something, so that the company, which say I am the owner of the company, I'm manufacturing some product and I'm selling it to the customer. For that, for the product to manufacture, we first need to source the raw materials. This raw materials will come from some suppliers. From the supplier, it goes to the procurement team. Then from the procurement team, it goes to the operation. Operation means where the actual manufacturing happens. So if I talk about a automobile, a car, so manufacturing of the car is the actual operation. Now to manufacture the car, I need steel, I will need cables, I will need tires, all these things. So from the supplier, I will purchase those things. Once the products are produced, I have to send it to the market. For that, I will go to the distribution. In the distribution, either I will have physical stores, I will have warehouses, I will have distribution centers, or maybe I have a e-commerce platform. From there, the customer will purchase the items. Now, all these connecting dots, say the movement of goods from the supplier to the procurement, then the procurement to the operation, all these interim connections are done by the transportation team. Here, different vehicles also will be available, different mode of transport available, either it be air, by rail, or by cargo. All these things will be there. Thereafter, I will have a reverse movement of the goods. For example, suppose you purchase a product online. Now you check the product, and if turned out that it is not fitting you, then you actually return. So that also there's a movement that from the customer it will go to the distribution center. Or maybe once the product service life is over, then you actually sell it to the Saraddi wala. Like, or maybe some other way, like there should be a mechanism to discard those items. Or there may be also a case where there the product will develop some poisonous items. For example, if you talk about the battery, it will have acids. Now the acid disposal will need specific care. So for that, the company also have a policy to bring those used product back to its own either supplier or the manufacturing plant. This we call as reverse logistics. Now this entire process, like including supplier, procurement, operation, distribution, customer, reverse logistics, transportation, this entire thing will constitute one supply chain. Now remember, in this supply chain, it is not only that only one company is involved, there might be multiple players will be involved. For example, the supplier is not my department, it is another organization. For example, suppose if I talk about the Tata Motors producing, manufacturing cars, it still comes from the Tata Steel. Then its cables, again, assembly will be done by somebody else. Similarly, in operation also, not that every operation I will be doing in house. For example, for my organization, I need is IT support. It's not necessarily that I'll design my own enterprise resource plan or maybe develop the entire system that I can outsource to an IT company. Or maybe my tax calculations, the finance department, that also I can outsource to a chartered accountant firm. For example, and similarly in manufacturing also, some part of the manufacturing also I can get it done from another part. Now this entire entities which are involved in this process are part of the same supply chain. So how we define a supply chain then? The supply chain is the network of organizations that are involved in the different processes and activities that produce value in the form of products and services in the hands of ultimate customer. Ultimate customer means us, like you or me. We are the customer. We'll go to the shop and we'll purchase something. And initially, we people used to think that the perception was the supply chain is only for the physical goods, but in practice, service companies also have supply chain. For example, a IT company also have a supply chain because they also need a delivery mechanism, servicing mechanism, and they also have outsourcing. All these thing activities are involved. Now let's see some examples how a supply chain might look like in practice. This is a serial supply chain. So, what are the entities involved in this supply chain? First is the farmer who does the farming and produces the grains. Once the grains are produced, it goes to the grain elevator. So, this is like some kind of big, some third party, maybe aggregators. They purchase from small farmers. They'll aggregate and do some pre processing in the grain elevator. From the grain elevator, it goes to the cereal producer. For example, it will do the peeling, it might do a processing, say from like raw rice, it will remove the cover, the brown cover, like then it will produce the actual rice, raw rice. So those kind of things. After that, it will go to the grocery wholesaler. They will do in they will pack those first. The cereal producer pack the cereals in big packets. Then it goes to the grocery wholesaler. In the wholesaler, they will distribute in the local region. There will be lot of retailers where the items will go. And in the grocery retailer, actual demand is realized. For example, customer will come to the shop. They will purchase the items as per their needs. Now, in all these interim points, like if you see these brackets, there the transportation freight will be involved and material handling mechanisms will be there. For example, cranes, those things. Now, these are the activities. So, in agriculture is growing crops, planting, land, then harvesting, those activities. Now, is transforming, which is done in the grain elevator or maybe in cereal producer. It's turning crops into food ingredients, cleaning, milling, preparing. For example, if we talk about dhan, from dhan to rice, these transformations are done in grain elevator. Next part is the converting, the making the product from the food grains. For example, if you talk about the policing, then you have say quality inspection. Say from the broken rice, you want to remove the broken rice, put only the good quality of the seeds. So those things will be done here. Next is the packaging. Here the product producing packaging and materials. For example, they'll put it in a small bags, maybe larger bags, which is go the customer. Maybe for example, atta, they'll 5 kg atta, they will packet one thing. So those will done in packaging. Next is the shipping. Once the packaging is done, then those items need to be sent to the wholesalers, distributors, or directly to the retailer if it is possible. Then selling is where the actual demand is realized. So here the making the food available to purchase. For example, either it will be stacked in the retail shop, or in maybe in the departmental stores, or maybe in showrooms. For example, in case of automobile, so those selling is done. And selling also include the marketing. So difference between selling and marketing is that selling is like you produce based on the forecast and then put and you use your effort to sell it to the customer. In case of marketing, it is a kind of you understand what the customer's need is, and as per that you produce and keep the items in a place where the customer automatically will come and purchase as per their need. Then final part is the consuming, where we purchase, we cook, then maybe we drive the car, we actually do the consumption. So this entire process is a serial supply chain. Now in between, there are also some entities which are not visible in the supply chain. Is like one is the reportings. Maybe they create the reports. They will keep stock of the data. They will do all the needful. For example, there will be ERP system where the demand at the retail store will be incurred. Then it'll go to the backend, based on which we do the forecasting. Then there will be also accounting firms, finance firms. Then there will be tax, laws, everything. All the firms will be involved in this process. Next comes the retail supply chain. This is a pretty complex supply chain when it comes to retail, specifically when it is e-commerce. Because in this era of globalization, the different parts of different products and their associated raw materials are sourced from different parts of this world. Again, there will be a lot of to and fro movement. For example, suppose it comes from Latin America, the raw materials are from the African countries. Raw materials will go to China, maybe Bangladesh, India, Singapore, Malaysia. There they will do some processing. Some processing also can be done in Mexico, in US. Again, those semi-finished products will again go to China, where the final assembly will be done. Once the assembly will be done, again it will go back to the respective market. For example, Europe, maybe in US, those things. So here, for example, there will be raw material suppliers will be there who will supply the raw materials request. For example, if in case of apparels, the textiles will go, or maybe in case of shoes, the leathers will be there. Then from there, it'll go to primary manufacturer. Primary manufacturer means which whose brand actually you are using. For example, if you are talking about a car, maybe in Maruti, so Maruti is the my primary manufacturer. If you're talking about you're using and retail components, for example, apparels, see what you can say Puma or Nike. So they are the primary manufacturer. After that, it will go to the warehouses or the wholesalers. Whereas suppose in one region, say if you talk about India, say in eastern region there will be one big warehouses. From there again, every state there will be a smaller warehouses, wholesalers. Then every district there will be wholesalers, and from there it will go to the retailers. Retailers is like your local shops, and from every retailer the customers will purchase the items. Again, the customers in comes in maybe coming in different forms. Maybe it will go to the company's own showrooms. For example, if you talk about Puma, you can go to Puma's own showroom, or maybe you go to the departmental store where the different brands will be displayed there. Again, the third will be like company's own website. You can purchase online, or maybe on a e-commerce platform. Maybe it's like Amazon or Flipkart. So enter all the demands will go to the warehouses. Now the first part, it is the purchasing, supplies and management, where the raw materials will come and reach the manufacturing team. Next is the manufacturing and logistics, where the manufacturing is done and goes to the warehouses. And last part is the distribution management. So in retail supply chain, the first this part is called as first mile, this is called as mid mile, and the delivering to the customer is the last mile. And while the physical flow of goods goes in the front side, say from raw material suppliers till the customer, the information flow happens in the backward. Say from customer, driven information will keep coming back and back, and the demand and planning, all the algorithms will run based on the demand. Next comes, we'll show you the supply chain of a computer, which is highly globalized and it's a very complex items. For example, if you see in this figure, the raw materials for the computer items, say the semiconductors or maybe what is the components, the composites. This will be sourced from, say this is Latin American country, then from Africa, the raw materials will come. These raw materials, if you follow the arrow, the raw materials will go from the respective countries to the module production subcontractors. So subcontractors are located in Malaysia, Philippines, Indonesia, Japan, Korea, all these things. If you talk about the number two, these are subcontractor. Now, from the contractor, the actual company is based in the US. It is showing the brand company. It's a US company. Now, the subcontractor will produce their own module, some part of the final product. Then those everything will be assembled, say in number four. Four is the contract manufacturer for final assembly in China. From China, the final product will go to the European Union, where the actual consumer lies, or the Europe or the US. Now all these arrows are the logistics. You have to maintain all the shippings, like that company might be also sitting in some part, say in Mexico. They do the packaging or do all those stuffs. Now here, if you see the process, there's a lot of activities involved. For example, it is not like you purchase some raw materials directly sent to the subcontractor, like this Indonesia. So here there will be a lot of custom activities will be there. They will be packing, say from different parts of this country. Different amount of raw materials will be purchased and it will be consolidated at some point. Those consolidated from there, trucks will go in large containers, will go to the seaport. In the ports again there will be cargo handling, like there'll be the containers will be loaded, there'll be custom activities will be involved, you need clearances. Once all this thing that cargo is loaded, again you have to decide which cargo, which container will go in which cargo, how many containers will go. From there again it will go to that destination country. In that country again you have to unload those containers from the cargo, and that itself is a big activities. Again there will be a lot of country like government regulations, like a lot of procedures you have to do. And for those containers you have to open up. From there you have to split the items into smaller trucks. That process is called deconsolidator. From deconsolidator unit it goes to the warehouse or centralized team, centralized some distribution center, and so on. Similarly for final product also, this movement also happens in that way. So it will be, so if you see in this process, one is trucks will be involved where the items will be carried to the port. From there there will be ships which will take those items to different countries, and in the different in those countries in the port also it will be unloaded. For that again material handling systems will be there, and again smaller trucks will be there. Again from the distribution to respective points, say if it is a finished good final product, from the warehouse to the retail center, there also much smaller trucks will be there. So this is a complex process. Now let's we see some some decisions, like what are the decisions involved in the supply chain. So all the decisions we can split into three categories. One is strategic decisions, tactical decisions, and operational decisions. Strategic decisions is something that you, once you take this decision, you don't change it for a, say for around 10 years. uh, these are like long term decisions. For example, layout, what your plant layout will be. So layout means, for example, if you talk about this part. Uh, if you talk about a medical, a health center, maybe a hospital, what the layout is. First, the patient arrive at the by the elevator or escalator, maybe some entry point that patients are coming in. Then either it go to registration counter or it will go to self-servicing kiosk. So where the patient will be registered, they fill up the form, they'll do the registration, maybe Aadhaar card entry, something. Once everything is done, you are ready to enter the system. Now in the system, either you go to the OPD section where the general doctor will be there, because if you're going for the first time, you go to the OPD and you check what actually your problem is. But if you are repeated, if you are already visited, second time you directly visit the expert doctor, which you have been assigned, took the appointment. Or once for the first timer, once the OPD check is done, again you will be referred to the expert doctor. Now after that, they will they will suggest some tests, for example, X-ray or maybe ultrasonography. Then you pay the charge for those tests, and either you enter the X-ray operation or you go to the ultrasonography. In X-ray, you do the X-ray machine, then the inspection will done. First, they will evaluate your things. They'll do a registration, maybe. Then they will prepare you pre-processing, maybe in case of say ultrasound, you will consume some liquid. They will some tracer. If they consume, they will prepare you. Then they'll send it to the actual machineries. After that, you will have say the doctor will prescribe you the medicine or something. Then you'll go visit the pharmacy, and you'll leave the system. Now here if you see, this is the layout, like which will come after what. For example, say I swap some of the things. Say I put the pharmacy here, somewhere here. Then what will happen? So there will be chaos in this. There might be a crowd in the system because first will go to the doctor, do the test, again come back at the beginning at the entry point. Again you leave, you'll go again here, exit. Then it will be big chaos. Secondly, suppose I again say suppose I put the X-ray here before the OPD section. Then what will happen? So unnecessarily people go moving here and there. So now this layout is a strategic. So once you build a hospital, you cannot keep changing the building. You say, suppose today you build the hospital and the layout is such that what I told, like the problems, like the OPD section is after the X-ray section. You build a hospital like that, and tomorrow you realize that there was a mistake. You don't again demolish the hospital and build it again. So that is a strategic decision. You cannot keep changing here and there. Next is the location of plants. Now this is the first, actually the first decision before the layout, like where your plant will be located. Okay, in case of suppose if you are in suppose in this in India itself, you are based in India and you want to decide where the location will be. Now some of the factors, one is power. For your all manufacturing activities you will need sufficient supply of power. That is the first thing. If power is there is, if there's frequent load shedding or power interruption, then you have to again source diesel or petrol for the generator. That will cost you additional amount. Then next is the land, because land acquisition is a big thing. So there will be different regulations to acquire land. First thing, there should be sufficient land available, and suppose whether is land is agricultural land or it's a tribal belt, some of the lands you cannot purchase. And what's the rules and what is the law, what is the taxation for the law for those land. Third thing is the transportation. You should have sufficient transportation logistic facility. For example, you cannot send one big uh, truck on a smaller road. So sufficient road connectivity and sufficient logistics partner should be available. And one important thing is the labor. Whether skilled labor is available, if it is available, is it sufficient? And what is the labor unions activities, and what are the rules and regulation or the laws pertaining to the law, because different states might have different laws. And what is the maximum working time or minimum wages, those everything you need to take up. Next is capital. This capital, now capital availability again is very crucial to the business. First you should have sufficient capital to to set up your plan in a part of the country. Suppose in some part of the country you'll get a lot of benefits, but the cost also will be more. That should come, like you should have sufficient budget for that. Again, there might also be cases where you should avail, you should be able to avail a credit from the reliable sources. For example, I'll say in some cases there might be issue of money laundering, so you cannot avail credit for those organizations. And suppose in case of globalization, in some countries there might be you all other factors will be favorable for you, but there might be sanctions imposed on that. For example, you talk about Iran, or maybe you talk about um, North Korea, or something. You might get labor at cheaper places, cheaper costs, but you cannot set up a plan there. You cannot outsource some activities there. And next, again, anything is outsourcing versus offshoring. This is also a strategic decision. So, outsource difference between outsourcing and offshoring is that outsourcing means I am giving some part of some task to an another organizations to perform. For example, suppose I am a automobile company. I will say give my all the IT related work to IT company. That is outsourcing. So they will do the things for me. They will bill me. I'll pay the bill. Offshoring means because of the economy of scale, because my labor is so costly in my country, I will just send some of my own team to work in some other part of the country. For example, say I have a retail chain which I am performing in US, but my data science team I will place in Bangalore. That data science team is still part of my own country, of my own company. For example, say I'm talking about Target Corporation. Target has operation in US, but the data science team of Target is based in US. They're working for Target and they're the employee of Target, so that is called offshoring. Next is the location of distributors, some subcontractors. For example, suppose if you have some of the factors here mentioned here favorable to you, but do you have the sufficient supplier in your nearby? For example, if automobile, you should have all the suppliers. There should be ecosystem for that, because most of the companies, some of the automobile companies, are based in this part, or maybe in Hosur side, or maybe in Gujarat, because they have lot materials and and logistic partner, all the subcontractors, they are available there. They have an ecosystem in place. So that's why that is one factor. Next is a diversification. Diversification is generally used for maximizing profit and mostly minimizing the risk. Diversification means I will jump into different segments of the market and I will design product for that. For example, if you talk about Coca-Cola, they are performing in three segments. One is soft drinks, like the cold drinks you're talking about. Next is Minute Maid, where juice kind of thing, and third is the mineral waters. In soft drinks, they have Coca-Cola, Diet Coke, Coke Zero, Fanta, Sprites. Then in case of Minute Maid, they have guava, they have mango, and this is a lot of segments they are working. They have a lot of products. So mainly three segments: soft drink, Minute Maid, and mineral water. Why you want to go for diversification? One major thing is, suppose this quarter your soft drinks are not selling as expected, so maybe your profit margins is lowered. So this will be compensated by maybe Minute Maid, because their sales might goes up. And third thing is a product manufacturing decision. Say in case of these different segments, you have this lot of products. For example, Coca-Cola, Diet Coke, these are different products. Now, how many items will purchase for individual product? That is a big decision, because based on the demand and based on, because once you decide the quantity, then you also need to procure the raw materials, and you also need the relevant labors and machineries. So these are all strategic decisions. Next, we talk about the tactical decisions. These are medium range plan. So strategic, we talk about the long range, maybe for next 10 years. Tactical is like for next 2 to 5, what you are doing. So it's like your strategy. You don't change the decision frequently, but at some point of time, you keep changing your decision. For example, vendor rating. Vendor rating is like is if suppose you are purchasing or you are outsourcing some items to the vendors, or you're sourcing, suppose you're procuring some raw materials from 3 to 5 vendors, then we allocate different bandwidth to those suppliers. For example, you're purchasing steel, so you're purchasing steel from 3 vendors. One vendor you're allocating your demand, 20% you're allocating to supplier one, 30% you're allocating to supplier two, and rest 50% you're allocating to supplier three. Now every year you evaluate those vendors. Suppose the vendors are not performing as per your criteria, then maybe after 1 year, 2 years, you will change that allocation. Maybe the supplier one who initially got 20%, it is performing better. You are delivering the raw materials on time, good qualities. Then next time you increase that share from 20% to 50%. But here you cannot keep frequently changing, like every month, every 2 months, you cannot keep changing this decision because there is an agreement in place. So there will be at least 1 year agreement will be there. You cannot change the allocation. Next is the jet implementation. Jet stands for just in time. For example, suppose you're procuring an automobile. Now different components you need, like different items, you need at different quantities, and you need to source these items from different parts of the country or maybe the world. Now whenever you ask, so suppose today demand additional demand of 100 units come, like somebody suddenly tell that this month I need additional 100 cars. You cannot suddenly produce those items, so because you need to have those raw materials available to you. To counter that, you actually store some additional raw materials in your warehouses. Now JIT philosophy tells that you reduce that inventory to zero. For that, what is required? First thing, you need a very reliable process, obviously, so that you don't need to keep backup for those things. Again, another buffer will be there for the operation. But main thing, suppose the suppliers are located nearby. Whenever you need additional items, suddenly you can go and purchase from them. So these are the JIT implementation techniques. You need the suppliers nearby you, need these raw materials nearby you, those things. Third is the collaboration, partnering, outsourcing. Again, collaboration partnering is like, uh, you collaborate. Suppose you don't have something, like you some technology, you collaborate with the different teams. Say for quality inspection, you don't have the expertise how the quality inspection will be done. That you go and have a partner who is expertise in this quality checking. Last is the vendor managed inventory. So what does it mean? Suppose in departmental store, different brands shops are there. Now, in case of vendor managed inventory, those respective brand will take care of the inventory decisions. You suppose you are the owner of the departmental store, you don't need to keep track of those items. You have a point of service where the customer will swap, and you have a ER system where how many items are sold will be entered. Now those data will be shared with the respective brands. They will know how many items previously you have shipped to the departmental store, how many items are being sold, and what are the remaining. Based on that, they will take a call when they will replenish those sales. How many items they will, when they will send the next shipment to the departmental store, and how much quantity. So this is the vendor managed inventory. For that, you should have agreement. You will need lot of trust because you are sharing your data with the another with your partners. So, and also there should be a mechanism where the partner should have an access to your ERP system. ERP is the enterprise resource plan. Basically, if you see in a departmental store where they will that they will the purchasing, the billing is done, you can see there they will entering the data, right? That is kind of a part of the ERP. This is the uh, main decisions which are relevant to us. These are the operational decisions. These are done. These decisions are being made on a day-to-day basis. Okay, so for that you need quick solutions and optimal solutions, because the last mile delivery where the products are finally goes the customer. So here a lot of decisions are involved, because if the decisions are delayed, and first thing, not only like you need to take the decision quickly, you also need to implement those decisions as soon as possible. Otherwise, the customers won't wait for you. They will go to the competitor or they will create noises. So now in operation decisions, what are the different types of decisions? One is maybe the scheduling. Scheduling means suppose you have a product which first some operation is done on machine one, after it go to machine two, machine three, then final product comes up. Now you have to take up like which product. Like suppose you have in the same set of three machines, you have some five different types of products need to manufacture. Now which item will go after what? And suppose and how many items? For example, suppose you have three products A, B, C. Now A have need to produce five items, B three items, C is under two items. Now how the sequence will be? Whether it will be like A B C, or it will be A A B B C C, or it may be A A B C again A A. So those are the schedules. The scheduling decisions it has when to do, when these items will be done, or when these activities will be done, and what to do, which activity I will do. And next the manpower, like which item, which manpower is required for this activities, and how those activities will be allocated to the manpowers. For example, the manpower again, the labor will have their own skill set. To produce one activity, you need a specific skill set, or maybe more than one skill set. Once you do the scheduling for the product, you also need to schedule the manpower, because unless that skilled person is not available, then you cannot do that operation. Next is the routing. In the routing we have two things. One is vehicle and raw materials. Like if you have suppose different in the plant, different segment is producing different types of products. Now the raw materials will be stored in a centralized place. Now from the centralized store, where the raw materials will go. And vehicle is like if you see in these figures, suppose I'm talking about the best example is the post office. Like at the beginning of the day, there will be a postman who will take up some deliveries, like some letters or parcels, and he have to deliver to customers. Now the beginning of the day, what are the tasks, what are the deliveries you will assign to a postman? Suppose this postman, he takes this route, so these are the customers he will serve. Again the another postman will serve this customers. Suppose if I assign this customer 5 to one second. Yeah, suppose if I assign this customer 5 to this postman, what will happen? He have unnecessarily he have to go here, 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 then here, longer distance, right? So these are like wastage. Like it'll like more the distance it travels. For example, if you're running a truck business, then you will have to incur additional cost, because you're making the truck to move faster, so fuel consumption is high. So you have to decide which, like how this grouping will be done, like how it will be clustered 7654. This customer now is a cluster. Now how you need a mechanism that 765 and 4 actually is your optimal cluster. So that is one thing. Next thing is your last mile. For example, Zomato or Swiggy, they also need to deliver those food to the customer. Now which delivery boy will be assigned which deliver, which shipment. So those are operational decisions, and you will have strict timelines. Like if you are producing, if you're promising that suppose you purchase, you're ordering food online in some say Swiggy or Zomato, they you will see that you will be delivered in 15 minutes or 16 minutes, then you have to honor that decision. So for that you need, first thing is quickly one thing is definitely you need to produce that food, but after that, that immediately that food should go to the customer, and the delivery boy should be available. Now how much delivery boy you should be having at any point of time, and how that delivery will be assigned to the delivery boy. So these are operational decisions. And next most important thing is the inventory. Inventory is like in supply chain, this is like more than 50 60% of the decision is actually inventory decision when this operational decision comes. So inventory is like what to store, where to store, how much to store, because you have thousands of products you are selling. Now for every product the demand might not be same, And again, the demand is distributed in different geography in different quantities. So in that case, say how much product you will store in which location. Suppose I in India, say I have uh, say in Assam itself, say we have Guwahati, Dibrugarh, Jorhat. We have four warehouses. Not necessarily that every product sales velocity is same for Guwahati, Jorhat, Dibrugarh, or Tezpur. So now you have to make an analysis like which product have more sales velocity according to you devise a policy. Like okay, if product type one in Guwahati, I'll just store 100 units. In Dibrugarh, 50 units. I mean Tejpur, it has more demand, so 150 units. So accordingly, you have to dynamically have to keep managing. And how much to store, where to store, what to store. And another thing is, for example, if you're talking about sweaters, so if you're storing lot of sweaters in say in Tamil Nadu, it's not going to sell that much. It is better required in maybe northern India, northeastern India. So accordingly, you have to make a strategy. And also, like in case of apparels, the human body structure also is not same. Maybe in some part of the country, people are taller than the other regions, so you need to have this XL, double XL accordingly need to distribute it. So those decisions are important. So these inventories, yeah, it looks like that inventories. Yeah, now this is the most important part of the supply chain decision. Now we talk about different types of decisions, operational, tactical, or strategic. A main problem is that it's a complex web. You don't make decisions in isolation. Generally, when we talk about, say, decisions, data science, AI, so we talk about solving a snapshot of the supply chain. But when you talk about supply chain modeling, you need to consider entire supply chain because these are the reasons. So first is the customers are no longer willing to wait for products and services. Nowadays, everything you need very fast. For that, you need to have quicker decisions and also in the implement those decisions very quickly. Otherwise, the customer will go to a competitor. And next thing is the customers are highly knowledgeable and demanding. Like nowadays, you can fool a customer. Like they will search different platforms for a particular product. They'll do their research. They'll talk to their friends. They will know what exactly is price will be, what are the features will be, what are the features of the competitive product. Like if you have same product if two different companies are producing, then they will also evaluate what are the features both the companies are providing. They absolutely know what are the features available in the market and what are the price for that. And next is demanding the customized product. Now every customer they want some kind of customized things. For example, if you talk about go with Dell products like Dell computer, like you can actually select how much is the what for a particular computer, what RAM you want, what's the RAM memory space, again hard disk, what is the size, everything you can do. So there will be some 100 types of computers available. So you need to have a flexibility in a supply chain where you can accommodate these customized products. Next is the impact of globalization. Now it is not like your entire supply chain is based in one region or one country or one state. Now this supply chain, as I saw you in the e-commerce or retail case, it is distributed across the world because you need to have a coordination mechanism to coordinate is different parts of this world. For example, one challenge might be suppose in US somebody is working in the daytime, for you it is night, right? So now how you'll coordinate? Or maybe you also as a manager sitting in US, you also need to visualize your supply chain in saying what is happening in India, what is happening in Singapore, what is happening in China. Then only you can make an informative decision. Next is increase outsourcing because this is another challenge because you need to have a lot of proper mechanisms to do agreement, to monitor, to penalize somebody if somebody is not working properly. And you have a coordination mechanism. There a lot of trust is required, and there is a lot of information sharing because generally companies don't want to share the data, competitive data. But in case of supply chain, you must share some portion of the data, and you need to figure out how you share and whom it you share. And next thing is the dynamic customer demand. Like demand is not very static. You don't say that every year only 100 cars only will be sold. It will vary. Then your supply chain also be robust enough to accommodate those dynamic demand. There will be sudden spike in the demand. So what will you do? For example, if we talk about retail sales, say on Big Billions Day, They suddenly there is surge demand, like so much of demand that you need to actually fulfill those things. Suppose if you have offered big billions there, you have accepted so many customer orders, and after that you tell the customer that I don't have sufficient inventory, so I cannot meet your order. Then what will happen to your business? So these things you know take care of. Next is geopolitics. Obviously, now we are going through a new world order. Like there's different parts of the country, the wars are going on, sanctions are being happen. Say in Russia, Ukraine war, there'll be sanctions on Russia. You cannot purchase petroleum products, unlimited petroleum products from Russia. Then Iran also have petroleum. You cannot purchase petrol from them. Then you have a lot of say different parts of the world. So again, there will be trade wars. Somebody will put additional custom duties. Then suddenly, so for last 20 years, you're sourcing the items from one country. Suddenly, they have increased the custom duty. What will you do now? So these are complex webs. Then next, the conflicting objective, which is the most important part of supply chain decision, because this is the case. Say you have four different units: sourcing, manufacturing, logistics, sales, and customer operation. So in manufacturing, if you see, they want long runs. Long runs means suppose if you're producing a product, they want the product batch size would be more. For example, in one run, they want to produce 1000 of the product. However, in sales or customer service, they want flexibility. Flexibility means if customer wants different customized product, they also want to meet that customized that product. For that, your batch size, the runs will be actually lower. Now the manufacturing team, there's a conflicting objective with the manufacturing team. Okay, next we talk about say warehouse. In logistics team, they want less inventory, smooth flow, less SKUs. Now if you talk about less inventory, manufacturing team actually wants a higher inventory because they want to minimize the risk. Suppose if when I talk about say one product, first is go to manufacture the machine one, then it goes to machine two and machine three, then the final product comes up. Now suppose unless the product comes out from machine one, the machine two cannot start. Now for that you need a buffer. So you already have a 10 buffer between machine one and machine two, so that machine one, if it is interrupted also, machine two is not interrupted. So they want higher inventory. But the logistics team don't want that. Next is the less SKUs. They want to have very fewer items because they also need to manage, accommodate all the items in their warehouse. But the sales, if you see, they want flexibility. They want different lot of varieties of products. So you can see if you suppose if you're designing an algorithm to minimize the optimize the inventory for logistics. Okay, one second. Yeah, if you're designing an algorithm or strategy for logistics teams only in terms of inventory, even though if you're getting an optimal solution, but that might not be acceptable to the sales department or manufacturing department. So when you talk about supply chain, you have to take the decision considering everything as one. Then only your solution will be useful. So when you talk about modeling the entire supply chain, it's really very complex. Yeah. So here are some use cases. Whether even any question is there, so I can take it up at this point for a minute.
Uh, I think, Gemini, I think we can take at, after your presentation.
After, sure,
Mhm.
sure.
So that will be good.
Okay.
Yeah.
So here are some use cases, some of the projects which I have worked, and I cannot directly reveal the company's name or maybe actual use case. So I have adopted those use cases to so that I can present. So it is like one of the oil and gas project. This is generally we talk about in oil and gas what supply chain is involved. You just need to drill and refine to sell the product. But this is one maintenance say supply chain here. So this is like one is the this is this North Sea. So in North Sea here one side is the United Kingdom. This is Netherlands. Okay, so in between in this in this sea there will lot of offshore rigs. You can see the small names. These are all drilling centers, like all offshore rigs. So here oil production happens. Now what the problem is, these rigs have thousands of items, thousands of different components, items, warehouses are located, not warehouses, equipments are located. Now you need to maintain those equipments or the machineries at a regular interval, or there might be some breakdowns which you also need to maintain. Now these are inside the sea, so you don't have a center like where the people lives here, they do the maintenance, or in the rigs also the number of people who can operate in one platform is also limited, because you cannot send some 50 people to work in one platform because it can accommodate only 10 people only. So for that, what we have two base locations. One is like in UK, the stars, like one is Netherlands, where you have all the maintenance department is there. Now see, in maintenance you have two types of maintenance work. One is preventive, one is corrective. Preventive is like, you have, suppose you have purchased a equipment at a regular interval of time, you need to maintain it so that that equipment doesn't break down. And there also one more is there, like we have lot of sensor data. Suppose there's a pipeline, there'll be sensors at every 1 meter 2 meter sensor available. From the sensor data keep analyzing, like whether the pipeline is working fine. If the algorithm predicts that this pipeline is going to rupture in next 1 month, you need to change that. So those are preventive. Corrective is like actually breakdown happen somewhere, so that machine, that entire rig is not working. So that also you need to do fix. Now base location, these are two base location, as I mentioned. It will have people stationed there. People, they have different skill set. There'll be some mechanical maintenance guy, some electrical, some instrumentation. And for one rig to fix, you will need, might be only one type of skill also required. Maybe you need the cross functional team, say civil, electrical maintenance, everything is required. Accordingly, you also need tools in those base locations, like hammers, wrenches, whatever is required, drilling, everything is there. Now on the beginning of any day, a set of people will start from the base location, and they will visit. Say they will go here, they'll do some activities from there, they will do here, again they will do here, but at the end of the day they have to return back to the base location. Okay. Now here your mode of transportation, these are, here it is ships. These people will go via ship or small boats. And route, yeah, as I mentioned, this route. Now you have to design your strategies. How many people will be sent at the beginning of the day to which rigs, and how many rigs they will perform this route, how they will move. For example, if you are just today allocating just a few, two or three, then if they have additional time, see, in half of the day everything is finished, then they will come back. So entire half of the day is lost. So one is like boat, that trip also will cost you a lot, and you have idle people in the base location. So you also need to find what is the route, how many rigs they will perform. And today say some of the items remain in one of the rig, next time when you send it to another routes, so what will happen to those unfinished items? No, this is the entire thing. Now how the supply chain is in this case. First thing, there will be work order days. Either it will be preventive or it will be maintenance. Like either is a breakdown or is a preventive maintenance. In preventive maintenance is like some preventive issues, like you have forecasted that this thing is going to blow after 1 month, so now itself you do the repairing. Or maybe another thing is like at periodic times, maybe every 2 or 3 months you need to operate on the boiler or something. Now there will be a work order raised on the ERP system. Now, once that is done, you have to check whether sufficient material is available or that many required labor is available. Now, better it will go to whether material is available or not. That you need to check. If you check the warehouse, if it is available, that's fine. If the material is not available in the warehouse, then you have to go to the material purchase team. From the purchase team, either you contact your contracted supplier, like you already have agreement they will supply those things. If it is not available, then you go to spot market. Spot market means you go to, say for example, how a vegetable shop is, you go to actually suddenly go to market and purchase the item. Remember, in spot market the product price will be more because you don't have an agreement. And once the material comes from there, it will go to warehouses. Now your material is available. Next you have to check whether labor is available. If it is not, then go to labor department, HR department. Then they have to either have to hire a full-time labor, or they might have to get a contractual employee. Now, if both material and labor available, now they will go to the maintenance schedule. Now they have to make the schedule like, oh, okay, these are the dates, these are the items I need to do. These are the maintenance items. I mean maintenance task I need to perform on these dates at those locations. After that, you have to check the routine, and before that, you also need to check the vehicle availability, like which vehicle will be assigned to which day, to which location, like then how many people will go on that vehicle, and what are the sequence, what are the routine they will take. So this is the entire maintenance scheduling supply chain. Now these are decisions at various point of time, not decisions, like these different algorithms or maybe the problem statements involved in the supply chain. Now, if you talk about the preventing issue, that is called predictive asset maintenance. So they will have a lot of sensor data which are generating data every 1 second or 2 seconds. So the billions of data will be there. Then you check two different like thermodynamic principles, physics, then corrosions, all these teams you coordinate, then build the algorithm such that you focus what is the service life of the specific component or specific pipeline when it is going to rupture or going to break down, so that before upfront proactively you can do the uh, necessary what you can say that maintenance activity. Now in case of supplier material purchase team, you need to have a supplier selection and evaluation, right? As I mentioned, you will have suppliers and you are allocating different demand to the supplier. Now periodically you evaluate whether supplier is actually giving a good material, or whether they are delivering on time. So these evaluate, if it's required, then you actually change the supplier itself, or maybe the allocation also it will change. Then once the supplier is if there's a contract with supplier, you also reserve some capacity with supplier. For example, that supplier actually is producing products to different companies. Now if you want your product to be on time, you actually pay him and tell that the 30% of his capacity is a reserve for him. So accordingly, you had need to have an agreement. So now you have to decide like which supplier should have how much capacity reserve, and once the capacity is reserved, how you optimally use this capacity to, and so that you also need to have a purchase, you also purchase some portion of that economically as per the agreement from the supplier. So these problems will turn up. Then inventory, in case of warehouse, you need to have inventory rationing. Like if you have warehouses at different location, then you have to figure out what product, how much, where it will be sold. Then space utilization. Now suppose the warehouses are not of infinite capacity. You need to accommodate all the products there with a given space, say on maintenance equipments. Now you should utilize the space effectively so that you can accommodate all the tools and techniques, tools and items there. Then inventory tracking. If you see a warehouse is so large, if suppose a demand has come, like somebody has make an inquiry like whether these items is available in a warehouse or not, you should have a sufficient a mechanism where you can actually identify, okay, this product actually is being stored there. And also you also need to have a mechanism where you track, okay, currently I have this many items, so that if that quantities comes below a admissible level, you actually automatically raise a purchase request so that you don't go out of stock. Next thing is, for in case of vehicle, you have mode selection. Suppose you have an option to go with different modes, maybe truck, bus, cargo, or maybe helicopter. How you select so that your cost is minimized, but you also might have the constraint like deadline. You should reach the rig early as soon as possible. In that case, instead of boat, you have to send it by chopper. Now you have to make a optimal plan for that. Then after that, which vehicle will be assigned to which route. In case of maintenance schedule also, you will have say some You have objective like minimum make span. Make span means suppose in case of manufacturing, suppose you have a system of three machines where this raw materials will go and final product will come out. Now when the first product is loaded in the machine and the last product comes out, that difference is called make span. So you want to minimize the make span. That means you want to produce the entire batch as soon as possible. And next is the maximizing the manpower utilization. You should have optimal number of people available to your shop. There should not be a shortage. There should not be very additional manpower. Otherwise you will just simply they will sitting idle, then actually your networking capital is stuck there. And next is last like one thing, minimum backlog. Backlog means suppose if you have a lot of maintenance activities involved, it's not necessary that you can do each and everything. So in that case you need to minimize the number of unattended items. Similarly for routing, you have this objective like minimum distance travel, on time delivery. There will be a delivery due time. Before that maintenance activity need to be completed. So that is one. Then minimizing the safety. Sorry, maximizing the safety. Sorry, it's a mistake. Maximizing safety, because there will be hazards if you are overloading, underloading the cargo, that ships, boats. That one. Minimizing cost. In all this thing, you also need to perform all the activities with minimal cost. So this is the oil and gas. Next, we talk about the wind turbine. So in wind turbine, these are the components. So you have a rotor. Rotor include the hub and a blade, which you can see like keep rotating this blades. Then this is a nacelle, and there is one tower, which is put in the corner, like the table and that tower you can see. So now, for one wind turbine, suppose you have four projects going on. You need to do the installation. One say in somewhere in Assam, somewhere in Andhra Pradesh, somewhere in Gujarat coast, maybe in Tamil Nadu coast. So these are four projects running projects. Now to meet the projects, you need sufficient number of wind turbine. Now in case of wind turbine, the different components of the wind turbine done is manufactured or maybe assembled in different parts of this country. If you see the labels, one is this the blade plan. Here is see this is the blade plant. This is placed in Andhra Pradesh. Again another blade plan. You can see blades. Supply is available for that plant. Supply is available in Karnataka. Then again supplier is available in Gujarat. And second part you had need to the Nassal, where a Nassal plant is again Tamil Nadu Nassal plant. And yeah, so similarly for towers also you have this tower manufacturing plant there, sourcing here. These are, see, you can see different parts of this country you have different components. Now you need to source the items from different parts. Then you have to manufacture those respective items in the respective manufacturing plants. Once that is done, you need to assemble everything into one wind turbine and send it to the production where the installation will be done. And in all these cases you need the transportations. Okay, so and again there also you need some further decision whether you manufacture those products in house or you send it to, so you get it from some other part. Now this will, let's see the retail supply chain that we already have discussed once. So this is how the material flow looks like in a globalized e-commerce platforms. So as I mentioned, like either you source some material from Latin America and African countries, then these are sent to like Asian countries, India, then you have Indonesia and Malaysia, then all the assembly is done in different parts of China. From China, again, a finished good, it'll go to Australia, it'll go to US, it'll go to Europe. So in all these things, as I mentioned, these have a lot of activities. One is shipping is there, then you have sourcing, consolidator, deconsolidator, cargo handling, then you have manufacturing, assembly, outsourcing, all these activities are involved. So these are some activities, say for in case of vendor, vendor managed inventory, then overseas port, like when you source from another country, in that country, once it's sourcing from another country, put it into one port, cargo loading. So overseas port cargo loading is there. Inbound port is suppose I'm importing some from India, I'm importing some items from US. So that is inbound port is my country's port. Overseas port is the US port. So inbound port, we have say unloading, government clearance, these activities will be there. Then for distribution centers, you have space forecasting, like how much space will be required, how much in based on the what is the incoming quantity, how much quantity already you are having. Then you have searching and sorting, then splitting large shipments into smaller ones because in cargoes large shipments will come. Then from the distribution you have to actually send it to different retailers, so small packages need you need to build up. Then local warehouses, they are also same, forecasting of inventory, forecasting of space, handling, order fulfillment is how much service level I want to maintain, say from different demands, different retail stores some demands are coming, or directly from e-commerce this many demands are coming. Out of that I have to meet to fulfill those orders. Then how I will make strategy, how I'll fulfill the customer's order. Okay, the customers may be actual customer, maybe retailers. And in stores also sales spacing, like if you go the display systems of all the departmental store, like which product will be stored at which location and how much self space you will allocate to a particular product. So these are the problems. Then you have display, sorting, packaging, again order fulfillment, and finally it goes to the customers. Right, so these are what I have to cover today for in case of supply chain. Now we'll talk about the brief about what is the carriers in supply chain. As far as data is concerned, like there will be a lot of management side, finance side, all things, but I'm talking about the carrier in terms of data. So one is like visualization reporting. You have say business intelligence team. You have reporting. You can be reporting analysis professional. So their job is to get data from different segment of the supply chain and put visualize in one segment, like in one place, so that you see how one part of decision is impacting on others. Then you know the what the problem in the supply chain, because solving the first step in solving a problem is first you need to know what the problem is. To know what the problem is you need to know what actually the what are the data, like you need to visualize the entire supply chain in one place. Next is analyze. For that you have data analyst, you have operation research analyst, you have supply chain analyst. So they actually analyze, find out the problem from the visualization. So if you have all the data in one place, now uh, you need to figure out what the problem lies. So you do different hypothesis testing. So different, you started with some assumption, and based on data you check whether your assumption is correct or not. For example, your problem might be now in your this year you have lot of your pile up of inventories. Now you need to figure out why the inventory pile up is happening. For that you need to go check in different days whether the supply is actually there is a stochasticity in the supply delivery, because of that you are purchasing more, or maybe your safety stock calculation is correct or not, or maybe your different is somewhere some inventory is lying idle in some part is shortage. This entire analysis this analyst will do. Next is the model. In the model you have data scientists, you have orange, you have data scientists, mostly data science, that you do them the AI algorithms, all things will done. Finally you have policy and strategy. There also is modeling. There's like we have supply chain network design. They design the entire supply chain, they evaluate different policies. And you also need operation research engineer scientist. Actually my what I am also currently doing is that. Okay, so what are the skill set you will require? Say for visualization reporting you need Power BI, Spotfire, W. These are visualization tools. You need dashboards on that. SQL is required for data pooling, for analysis. Python R is kind of your calculator, like you try program all your algorithm in these platforms. There might be MATLAB, other things also. Since these are open source, these are widely used. And on any logistics arena are the simulation. They will do the queue, or they will do supply chain visualizations. These are the softwares. There are a lot of things, tools, but these are generally primarily its use. Yeah, thank you. If you have any question, let me know.
Uh, Thank you, Jaimini.
Yeah,
So I think, yeah. So this talk is very informative, and I feel our audience will be very much benefited from this talk. And you actually give much information on this supply chains, how to design, mostly on design part you talk about mostly, and where actually we need to use data science things like during the decisions times. So thanks for the nice presentation.
Thank you.
Uh, we have actually few questions.
Okay.
First question is from Hiday. He actually asked one question regarding security. Can you shed some light on the safety and security measures for data science in supply chain to manage the risks that could threaten each part of the supply chain process?
Okay. Yeah, that is a good question. So here, one thing I talk about in case of say safety or risk safety terms, we talk about this maintenance scheduling supply chain. So one is you talk about I talk about the preventive asset management. One is that is a safety. For example, suppose I have a pipeline which is carrying crude oil from one location to other location. Now that is the crude oil is going in high pressure at air. So you need to know the thermodynamic properties of the pipeline. So for that, you have different sensors uh, installed there. So one is from based on the environmental condition and what is the pressure, temperature profile in the crude oil. So how you predict that this after beyond a certain envelope this pipeline will rupture. So these are some of the algorithms we can develop. And apart from that, there will be say in case of supply chain disruptions. If you are talking about disruption, is definitely a major problem now because if you see the geopolitics, the supply chains are highly disrupted now. Say because of different ongoing wars or maybe trade wars, different sanctions are being imposed. So currently, the companies are adopting different strategies. One thing is that somewhere we're feeling that there is a reverse globalization also started happening because some of the companies they are actually pulling their outsourced manufacturing plant to their country who are actually the manufacturing actually where the actual company is located. That is one thing. They are also like one thing is diversification in terms of manufacturing. For example, initially I say manufacture everything in China. Now I am actually splitting that manufacturing into different parts of the country. For example, if I'm serving European market, so I'll put my manufacturing or assembly somewhere near Turkey, maybe on Lebanon, those areas in Middle East. Or again, one another. If I'm in US, I am also setting up one assembly or manufacturing plant in Mexico, and those things. Is that answer your question, or you have?
Yeah, I think so.
Okay.
Thanks, Jaimini. So
And
I
also
had
this
one
like
question
one is like
regarding
in case of
the supply
one more
chain
thing like
career.
in yeah, one more thing like in case of risk, we also talk about in terms of inventory is the safety stock. That is also risk mitigating. Suppose if you're going out of stock, then your entire manufacturing plan will be impacted. So you need to know what is the safety stock I need to maintain. Safety stock means the buffer. Additional items I am keeping is buffer is for finished good like final product or maybe raw materials or maybe semi-finished product. Okay, yes, carry on.
Okay, thank you. Yeah. So I had one question regarding the career of pursuing the career in the supply chain management or
Yep.
using like different careers, whatever is there. So that already you answered. So I think we can skip that. Uh, I have another question. Like when you design a supply chain system, okay, like first, as you mentioned, first you simulate that, then you deploy to the actual scenarios.
Hmm.
So, how to measure the stability? Like, is there any AI-based like measure to measure the stability of a
Okay,
system?
so here one thing, the supply chain design is not actually an AI problem. So inside supply chain, different snapshot actually is AI. When we talk about supply chain design, so we not don't talk about stability. We also definitely we have the confidence interval. So we have three sets of decision, right? Strategic, tactical, and operational. So when design supply chain, first you think about the strategy. For strategy, you need to actually evaluate different options of setting up the plan. In case of layout design, you have this arena, so they have the queuing mechanism. Suppose if you are placing different department in different order, how you enter queue, like enter system will react. React means like what your objective will be, either minimizing the number of people in the queue. For example, if when I talk about the hospital, what will be a queue size, what will be the service level, so how fast a patient is evaluated, and what is the workload being balanced across different departments. So those things, based on some statistical things, we do the simulations, then we check the queue. After that you go for tactical things. In tactical cases, again, base, these are not like very fast every day you run the algorithm, so this accuracy, those things we really don't measure. We what we talk about, like, what is my risk means, suppose if one supply is not delivering me product, this product on time, how would this impact will be cascading in the supply chain, that we evaluate. But in operation case, definitely this AI come into picture. So for example, when I talk about the scheduling, so not scheduling, the predictive asset management. So they have their algorithms, like how you, what is your confidence interval, and how accuracy, and what is the other one, precision. These two things we check, like how many times your algorithm actually is predicting correctly the failure. Is that answer your question?
Yeah, that's thanks for that. Yeah, and another question just came to my mind. For example, when you design a supply chain system, like you design a final version, for example,
Hmm.
okay, by considering different attributes from the real scenarios, like how you measure like how likely that system will work. For example, when you actually use that supply chains for the whatever use case you have.
Hmm. Again, come the what the actual question was, how you.
Or like how likely, for example, you design a supply chain system,
Hmm.
okay,
Hmm.
then after some time maybe you want to deploy that in your use case,
Hmm.
okay,
Hmm.
then how you estimate like how likely that design supply chain system will work,
Okay.
how you evaluate that.
Okay, that is one thing. So for that is what mentioned. They say if you talk about scheduling problem, your objective may be minimizing the make span, or maximizing the manpower utilization, minimizing backlog. See, these are the objective, and based on some constraint, we go for this operation research techniques. So there you say you evaluate different options. You go for the dual price. Like dual price is not like the price is the money one. Dual price is the what the rate of change of the solution if you change the constraint by unit amount. So these are some evaluation techniques are available. So if I relax, suppose I want to produce three products. Every product will consume different two types of raw materials, but also have this many limited raw materials only. Now how many items I will produce for how many quantities based on the revenue, so that my profit is maximized. So in that case, once I get a solution, we get, suppose my resource availability I have increased by one, how my solution is changing. That is we call as robustness. That is one point. The next thing is like, suppose evaluation case of thing. Say for example, over the layout will be. In the layout, definitely I talk about the queue systems. If I have a estimate for patient arrival, that is what we go for the distribution for, not distribution, what is called the probability distribution. We need to fit the curve, like which arrival pattern it is getting, like it is following, is a Poisson distribution or it is some other distribution. So that is like from data science perspective, we estimate the parameter. Okay, this is the arrival pattern mean, and this is the standard deviation. Based on that statistical distribution, I just simulate the queuing system, like my arrangement. Now for arrangement, I will have initially start with some business hunch. Okay, I know that after registration this patient will go there. This is my business like my hunch. Based on the hunch, I'll design a preliminary model. Then one is the input will be definitely those statistical distributions. Then we'll evaluate, we'll keep the system running on the virtual system. Now again I will keep changing. Okay, these are the parameters, I will now will change by one unit, and how the system will change. If the system is changing too much, then again I have to go back to the business, I go to historical data, I have to check actually what exact parameter will be. Otherwise, if the system is robust, then it won't react much. Then I'll say, okay, if I do this estimation, if the estimation is changed by 25% also, my final solution actually is changing just by 5 or 7%. Now you can design the system in this level. You can either option this and this. There won't be much difference. So yeah, does it answer that question?
Yeah. Thanks
Okay.
for your answer.
Yeah.
So we have another question. This is the last question actually, from Ravin Sharma.
Okay.
He asked, "ZIT inventory management relies heavily on precise forecasting. Are there any potential risk?"
For forecasting.
Yeah. So for
Yes, definitely. Yeah.
ZIT inventory
Yeah.
management,
Yeah.
he told like it is heavily relies on precise forecasting.
Yeah.
Are there any potential risk?
Definitely, yes. Your forecasting should be very accurate. If it is not accurate, either you make some activities in house or you pull your suppliers in your periphery, so that tomorrow if suddenly there's a spike in demand, you quickly go and tell the supplier I want these things, and accordingly your pricing also will change. Definitely forecasting is very important in case of JIT. That's why 100% GIT is not possible, so far is not possible. They generally companies use a mix of GIT and still they maintain some buffer. Yeah.
Hello.
Yeah.
Okay, so that was the last question actually, Jaimini.
Okay.
So, thanks again for your nice presentation and a very informative session. And I'd like to thank for accepting our invitation for delivering a session on supply chain management. So maybe in the future also we'll invite you as a expert 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 in this particular area, and maybe hope we'll do some other works also. Okay.
Sure,
Thank you. Yeah,
sure.
thank you,
Thank you, and
thank you,
thanks to you and the entire team for giving this opportunity. So I'll be happy to come back whenever is required. Thank you.
thank you. Yeah, thank you. So I think Sasank, you can maybe stop the lives maybe. Okay.
Sure, sir.